this question, which was asked in physics board exam of CBSE last year in 2022. This question says that photoelectrons are emitted from a metal surface which illuminated with UV light of wavelength 330 nanometer. The minimum amount of energy required to emit the electrons from the surface is 3.5 into 10 raised to the power minus 19 joule. Calculate the energy of the incident radiation and the kinetic energy of the photoelectron. Okay, so let's start. So this question is based on Einstein's photoelectric equation. Einstein's photoelectric equation, and this is very famous equation, and because of this explanation of photoelectric effect only Einstein got its Nobel Prize in 1921 or 22. I don't remember exactly. Anyways, so if you know Einstein's photoelectric equation, it's very well. But if you don't know, you can watch my one of the videos I have made on photoelectric effect. There I have introduced and explained Einstein's photoelectric equation. Anyways, so let me write the Einstein's photoelectric equation. It says that the emitted kinetic energy, maximum kinetic energy of electrons emitted from a photo surface is given by h nu minus phi. So here nu is the frequency of incident radiation, and h is Planck's constant, and phi is the work function of the metal, and Kmax is the kinetic energy. So suppose you have this photoelectric material, light is incident on these photoelectric materials, and light has frequency nu. When light comes here, electrons get ejected from this metal surface, and these electrons get ejected with certain velocity, or they have certain kinetic energy, and the maximum kinetic energy of any electron is given by this Einstein's photoelectric equation. And before coming out of this metal surface, electrons spend some energy to overcome the attraction force of the nuclei present in the metal. So that amount of energy is spent to come out of the metal surface, that is called work function, or we call that phi. Anyway, so this is the equation we will use here in this question. Okay, so in question it is given that surface is illuminated with UV light of wavelength 330 nanometer. So directly frequency is not given. They have given the wavelength lambda as 330 nanometer, and the minimum amount of energy required to emit the electron from the surface is this. So minimum amount of energy, this is called work function. So work function phi they have given as 3.5 into 10 raised to the power minus 19 joule. The question is the energy of the incident radiation and the kinetic energy of the photoelectron. So let's do the first part first. The energy of the incident radiation. So incident radiation is electromagnetic wave, it is light. So that's energy will be given by energy of a photon, and that's it. So this experiment, photoelectric effect, that is a very important experiment that proves the particle nature of light. Okay, and that particle we call photons or quanta, and energy of a photon is given by equal to h nu, or you can also write nu is equal to c upon lambda. So you can write in terms of wavelength also, so hc upon lambda. This is the energy of a single photon. And so here energy of the incident radiation will be, you will use this formula as lambda is given in the question. So Planck's constant h value is 6.63 into 10 raised to power minus 34 joule second. This is given at the beginning of your question paper. And into c is speed of light, we will write 3 into 10 power 8 meter per second, and this whole thing divided by lambda, which is 330 nanometer, means 10 power minus 9 meter. So now all the values are in SI units. So let me solve this. So 3 divided by 330, it will be 110, and let's calculate 6.63 divided by 110. It will be 0.06027 and 06027, and multiplied by 10 raised to the power, this plus 8 and plus 9 will be 17, and minus 34 plus 17, how much this will be? Plus 34 minus 17. It will be 17, right? So minus 34 and 8 plus 9, 17. So it will be minus 17. So this energy is 6.027. So you can write it 6.03 into 10 raised to the power minus 2 will come here, so minus 19 joule. So this is the energy of the incident radiation. And now we'll come to the second part of the question. Second part of the question is kinetic energy of the photoelectrons. So maximum kinetic energy, that we will use here this photoelectric equation. K max, that will be h nu, that is the energy of the photon, minus phi work function. So this we have already calculated. H nu or Hc upon lambda, they are the same thing. So we will just put the value 6.03 into 10 raised to the power minus 19. Minus phi is given in the question, that is 3.5 into 10 to the power minus 19. So you will write it as 6.03 minus 3 minus 0 will be 3, and 10 minus 5 will be 5, and then this will be 5 minus 3 will be 2. 2.53 into 10 power minus 19, or you can simply write, drop this 3, and the final answer will be 2.5 into 10 raised to the power minus 19. So we will give only one decimal place in the answer, as only one decimal place was given in the question. So 2.5 into 10 raised to the power minus 19 joule, that's your answer. So we found energy of the incident photon, incident radiation, and kinetic energy, maximum kinetic energy of the emitted photoelectrons also. So that was the question, and that's all.